The essential question for today's lesson: what are the key characteristics of solving an absolute value problem, and the things that you need to remember to look for when you're solving those absolute value problems. So we will start by looking at two possible solution outcomes for absolute values. So the first one is that you have a positive case. If you recall what we talked about in class, we have an absolute value of x being a distance from something. You have the positive case and you have the negative case. For example, if the absolute value of x equal to 4, then we're asking what is the distance, what number has a distance from 0 equal to 4. So that means x could be a positive 4, which is 4 units from 0, or x could be a negative 4, which is also 4 units from 0. So we're going to use this idea to help us solve absolute value problems. So let's take a look at an example. Okay, so we have the absolute value 2x plus 4 equal to 5. So using the idea that I just showed you with the absolute value of x equal to 4, we're going to take a look at what's inside the absolute value. The 2x plus 4 is either equal to a positive 5, or the 2x plus 4 is equal to a negative 5. That's the part that goes inside the absolute value. Once you set up those two possible cases, you then solve each one individually. So for the one on the left, we subtract 4 from both sides. 2x is equal to 1. Divide 2 on both sides. X is equal to 1/2. So that's one possible solution. Now we solve the next one. Same process. Subtract 4 from both sides. 2x equals negative 9. Okay, it's a negative 5 and a minus 4. So that gives us a negative 9. Divide both sides by 2. X equals negative 9/2. Or you could look at that as negative 4.5. Either one will be accepted. So these are our two possible solutions. Now, once you get your solutions, you need to check to make sure that they work. So when you do the check, you must check in the original equation. So you need to go all the way back to the absolute value equation and plug your numbers into that. So you're going to do two separate checks, one for each possible solution, and verify that they work. So in the first case, absolute value 2 times 1/2 plus 4, absolute value equals 5. We're not sure if it equals 5 yet. We have to evaluate the left hand, or the right, left, sorry. You have to evaluate the left-hand side. You're not going to do anything with the 5. The 5 is going to carry down as we go through and evaluate the left. So inside the absolute values, 2 times 1/2, 2 goes into 2 one time, so 1 times 1. That's 1 plus 4 inside the absolute values. Then you do 1 plus 4 is 5. Don't forget, we haven't taken the absolute value of the 5 yet. We're going to do that next. 5 is equal to 5, so that one does work. Now we're going to do the next one, negative 9/2. So we have absolute value 2 times negative 9/2 plus 4, absolute value equals 5. So we're going to check and see if that one works. So working inside the absolute value, 2 goes into 2 once. So that's negative 9 plus 4, absolute value equals 5. Inside the absolute value, negative 9 plus 4 is negative 5, equal to 5. And the absolute value of negative 5 is 5. So 5 is equal to 5, so it does work. So both 1/2 and negative 9/2 are our solutions. Next example. Note with this one, we have some numbers outside. We have some numbers outside the absolute value part. So when you are going through and solving an absolute value equation, you need to make sure that you isolate the absolute value first. That means we're going to get the absolute value part all by itself. So we have to get rid of the 7 part, and we have to get rid of the 3 part. So we're going to start by adding 7. It's just like solving a regular equation. You take care of that add subtract part first. So then you have 3 times the absolute value for x plus 2, absolute value equals 18. Now what I see a lot of students wanting to do is distribute the 3. You cannot distribute the 3 in this case because these are absolute values, not parentheses. You can only distribute with parentheses. So these are absolute values. We're not going to distribute the 3, but we do need to get rid of the 3 in the front. So since it is a multiply, 3 times the absolute value, opposite of multiply is divide. So we're going to divide both sides by 3. So then on the left-hand side, that gives us just the absolute value for x plus 2. Absolute value equals 6. 18 divided by 3 is 6. Now we're going to split that up into the 2 possible cases. Okay, now it's a problem like the first example we did. So you take the part that's on the inside, split it up into the first case, which is 4x plus 2 equals positive 6. Then we split it up into the second possible case, 4x plus 2 equals negative 6, your positive and negative options. So now we're going to go through and solve each of those 2 equations. Subtract 2 on both sides, 4x equals 4, divide by 4 on both sides, x is equal to 1. Other equation, minus 2 on both sides, 4x equals negative 8, because it's a negative 6 minus 2. Divide both sides by 4, you get x equals negative 2. And again, as before, we need to check our solution. So we'll do the check over here on the right. When you check, again, you must check in the original equation. So this is the equation that we're going to use to do our check. So we have 3, absolute value, 4 times x. So in this case right here, our x was 1. So we're going to put a 1 in there, plus 2, absolute value, minus 7 equals 11. So we're going to check to see if that works. Remember, the 11 does not change. We're not changing the 11. If you add 7 and divide by 3 in your check, you do not get credit for the check. That's not checking. That's doing exactly what you did before. So to check, we're using a different process. You've plugged in a number. You have numbers on the left-hand side. You're going to evaluate using order of operations. So we go inside the absolute values. Absolute values are like grouping symbols. So you go inside the absolute value. 3 times the absolute value. You do the multiply part first. 4 plus 2 minus 7. Finish inside the absolute value. 3. Absolute value of 6 minus 7. Then you actually do the absolute value part. So 3, now it's a times 6. Just the 6, no absolute value, because the absolute value of 6 is just 6. So 3 times 6 is 18, minus 7, 18 minus 7 is 11. That did equal 11, so it works. Now we're going to check it with the negative 2. So we have 3, absolute value, 4 times negative 2, plus 2, absolute value, minus 7 equals 11. So we're going to check this. 3 times, 4 times negative 2 is negative 8, plus 2, minus 7. Finish the inside of the absolute value. So negative 8 plus 2 is negative 6. I've not done anything with that absolute value yet. Those are still absolute values. Equals 11. The absolute value of a negative 6 is a positive 6. So now we have 3 times a positive 6 minus 7 equals 11. I'm going to finish over on this side. So it's 18 minus 7 equals 11. And 18 minus 7 is 11. So it does work. So our solutions are x equals negative 2 and x equals 1. One more real quick. So just as in the previous one, we want to isolate the absolute value first. So we're going to minus the 5 on both sides, get the absolute value, x minus 2 by itself equals 2 minus 5 is negative 3. And hopefully right now something jumps out at you. If you recall in class, we talked about how an absolute value cannot equal a negative number. And in this case, we now have an absolute value equal to a negative number. But that's not possible. So then your solution would be no solution. Okay, here are a few problems to work on. Remember to put these on the left side of your notebook, and we will check them in class next time.